So then we come to the first lecture of this topic, which is known as EM waves or electromagnetic waves. I think we have discussed something about EM waves in the previous classes. Basically, which class we had done EM waves? Yeah, this I talked about EM waves. That EM wave consists of perpendicular magnetic fields and electric fields. Then we had put something, and then we had made the electric field to move in one direction. Which topic had we discussed this thing? EM waves in a very short discussion. Do we remember that topic, beta? Well, that topic was polarization, in which we talked about EM waves. Light is an electromagnetic wave. It basically consists of electric and magnetic field, which is perpendicular to the direction of propagation of wave. The magnetic field is very weak compared to the electric field. So we took the field as electric field, and we did find out that if you put something which is known as a polarizer, and you allow unpolarized light to pass through it, electric field will only pass parallel to the axis of the polarizer. This is known as polarization of light. Do we remember it, bacha? Yes or no? No, yes. Only two answers for this. Okay. Well then, we will begin from where we ended that discussion. We had ended that discussion with the concept of that EM wave is nothing but a combination of electric and magnetic field, and now we are going to see that thing happening. And again, this is a screenshot of your sheet that I'm going to show you, and here it comes on your screen now. Transverse nature of electromagnetic wave and its properties. This is how I start this chapter. Electromagnetic waves. The idea was given by none other than Maxwell. We will be hearing more about this Maxwell in this chapter, because this chapter is all about Maxwell and what Maxwell did. So basically, electromagnetic wave, don't have to go through into entire theory, whatever they are there, whatever it is there. The EM wave basically consists of an electric field which is changing with time. Maxwell said that electric field that changes with time produces a magnetic field which changes with time as well. Therefore, and these two fields are mutually perpendicular, and that is how we arrived at the concept of electromagnetic wave. What are electromagnetic waves? We have discussed this. Electromagnetic waves are those waves in which they are sinusoidal. Sinusoidal means in the form of sine wave, variation of electric and magnetic field. So both electric and magnetic field are varying with time, and they are in mutually perpendicular direction. A time varying electric field creates a time varying magnetic field. Both are varying with time as sine waves, and they both are perpendicular to each other. They are also perpendicular to the direction of propagation of wave. Do we understand this? EM wave consists of electric and magnetic fields. Both are time varying, both are perpendicular, and they are also perpendicular to the direction of propagation of wave. I'll give you a minute to note this thing down. Well, then let's move ahead and see how this time varying electric and magnetic field are looking like. As you can see, this is the direction of propagation. The wave is propagating along x-axis, and you see electric field, electric intensity, and magnetic field. They are both perpendicular to each other. So basically, if wave is propagating in the xy direction, Both of this would be in the YZ plane. Do we understand this? Yes or no? No, yes. And the speed of light is given by this formula 1 by root over mu naught epsilon naught. Mu naught is permeability of free space. Epsilon naught is permittivity of free space. Mu naught is coming for magnetic field and epsilon naught is coming for electric field. Do we understand this? Magnetic field is written by B. Electric field is written by E. Therefore, light is an electromagnetic wave and the value of this thing is 3 into 10 raised to the power 8 meters per second and it comes from this formula. Please remember this formula. C is 1 by under root mu naught epsilon naught. I'll give you a minute, only a minute to win it. So let us move ahead. What we have seen is electromagnetic wave consists of electric and magnetic field, both varying sinusoidally. At the same time, both are mutually perpendicular to each other. This is how the equation of this will look like. Remember, it's the equation of a wave, a progressive wave. This is the electric field ka wave. E is equal to E naught sine omega t minus x by c. Remember, E naught is the amplitude. Omega is the angular frequency. T is time, x is the position in space, and c is the speed of light. Do you remember this formula from waves? Yes or no? No, yes. Similarly, we have formula for B. B is equal to B naught sine of dash omega t minus x by c. Omega is angular frequency. Remember, both the angular frequencies are same. The speed of light is also same. The speed of the wave. Do we understand this? If the electric field is along y-axis, magnetic field will be along z-axis. Then the electric field, then the wave will be moving in the x direction. Both fields are perpendicular to the direction of electromagnetic wave and hence electromagnetic waves are transverse in nature because particles are oscillating in a direction which is perpendicular to the direction of propagation of wave. Do we understand this? Yes or no? No, yes. I'll give you a minute to note it down. Have you noted it down, beta? Okay, then let's move ahead. And we write this pointing vectors. We just need to remember the formula of this pointing vector. The pointing vector is a vector that describes the magnitude and direction of the energy flow. In which direction is the energy flowing? And the energy is flowing perpendicular to both electric and magnetic field. Do we understand this? It is flowing perpendicular to the direction of electric and magnetic field. So it is E cross B divided by mu naught. You will have to remember this formula. So remember this formula. This is the magnitude of pointing field vector and it represents the rate at which energy flows through a unit surface. I'll give you a minute to note it down.